Hello again, it's Cliff here from Down Under. Just about coming to the end now of this series of videos on building your own standard enclosure. I thought I'd put together a few clips just to assist you with your plans and designs. If you are thinking of building one, I'll try and combine a few ideas together here. Cheers. Okay, well, how small are these compact enclosures? Let's put some numbers on it with a tape measure. Let's work in English, in inches, because I know a lot of you viewers are in the US of A. Okay, so this very compact 1100 enclosure is 55 inches wide. Alright, to put that in proportion, a 770 standard enclosure is 61 inches wide. This wider enclosure here is that is 62.5 inches wide. Thank you. That's 62.5 inches wide, and an 1100 standard enclosure is 80 inches wide. That puts it in perspective. Okay, so these videos have been about the front of the enclosure. But if you want to build the enclosure entirely yourself, obviously you've got to consider the ends or either side of the enclosure. So if I was going to start again now, I'd use this design, which is specifically designed around these sliding doors. And I'll just reiterate one of the features of this design, in case you've missed it in a previous video. So the side panel is a simple removable insert. See that there? It just pops out. Automatic door opening. And you can get at the electrical cabinet this way. You can get right in here to work on the electrics should you ever have a fault. Alright, and but you can also get to it from the front, but you know, that's probably a really nice feature to have. You just slip in an insert there. So that means that this, let's see if I can show it, this door is a simple little structure. I've got a gusset there to strengthen it. So it's just a simple little wall about 10 inches deep, and the door hinges off that. So you've got the absolute maximum of access with that design. And on the other side, or the other end of both enclosures, I've got what you could call a letterbox flap. That keeps the coolant out and allows you to have a compact enclosure, and also allows maximum X travel, so the table can slide through there on the occasion where you have an extremely long travel. That means that you can have the whole machine quite close to a wall and still have room to walk down between the machine and the wall and have a small enclosure, and only have that space that you use to walk down between the machine and the wall utilized occasionally on maximum travel. Obviously there's a risk there if you had small children or a large dog that you wouldn't want them running free at that particular moment. So if you've got limited space and you build a small enclosure, you can park your whole machine quite close to the wall or in an alcove if you've got an alcove, and just allow enough gap so that you can wriggle around the side of the machine when the table is in its normal central position, and only on extreme X traverse does it protrude through that end of the enclosure and come almost to the wall. I just want to make sure you guys understand the point of it. So you can have a flap on it if you're using a lot of flood coolant, but you might find that you're not using a lot of flood coolant, and the coolant doesn't reach that far because it's quite a long way to there. So you could start off with just a cutout, see how you go. If it becomes a problem and you're getting it dripping down at that point, then you could install the flap. But the advantage is that you can have a smaller enclosure and have it right up close to the wall with just enough wriggle room so you can get round the back of the machine and the side of the machine for maintenance. Let's just have a look at this on a drawing here. So you've got a small enclosure, and on extreme X travel it comes almost to the wall. There's just one caveat if you do that. If there's any chance of a child or a creature or yourself getting in there while the machine's running, then please build some kind of a safety little barrier there that you can take down when you want to go behind the machine, but it stops anyone from ever accidentally getting in behind there when you've got Extreme X travel traverse. You don't want any disasters. So with my new enclosure that I've just built, I've just utilized the existing end piece here, which is just a square of inch by inch angle iron framing with a piece of acrylic let into it. And that's not the optimum design. I think that this design is better, but it's a wider enclosure, and so I don't really need access for the door. The door can open fairly freely there because it's a wider enclosure. The electrical cabinet door can open fairly freely there because it's a wider enclosure. So rather than remake all that at this stage anyway, I've just left it a plain end piece. But I wouldn't copy that. If I was you, I'd copy this design. But as far as the stand's concerned, I like this design better. And I've gone over that in one of my first videos on this series. So if you've missed that, have a look at that. So there's just some sheet metal panels around the stand, transitioning into the enclosure. I won't give you dimensions or drawings because everybody's going to be in a different situation. Some will already have the stand and you want to marry it to a new enclosure. Some will have one size machine, some will have another size machine, and obviously there's a whole lot of variables there. So this series of videos is just about different concepts, different ideas, and you'll need to work out the final dimensions. But as far as those panels are concerned, and the sheet metal work, don't be put off by what's involved in that. It's really simple. All you need to do is sketch what you need with some dimensions. For example, there are those panels I was talking about. And you might fold up a small piece of sheet metal or wire to the actual profile you want, and then do a sketch with the different lengths. There might be 3 or 4 lengths. Go down to your sheet metal shop and get them to fold it up on their press brakes and big machinery, guillotines and things. You'll be amazed at how cheap it is. You can get it folded up out of quite thick sheet metal, say 2mm thick, 80 thou thick sheet metal, quite cheaply. And then you can cut these on the end, miter them together, you know. But get the sheet metal parts, the big sheet metal parts made out. It's only a few dollars, and they can be folded up. And you can even ask them to TIG the corners here and there if you want. It's all very reasonable. Oh, a note on sheet metal shops. Don't go to a sheet metal shop that specializes in roofing and flashing, because they'll have very light folders and guillotines, and they won't be happy with thick section. Go to more like a large general engineering shop that has a sheet metal section, and because they'll have big press brakes and guillotines that can cut, you know, 3/8 thick miles of steel, huge equipment, and get them to give you an estimate first so you don't get caught out. But you know, I imagine in the US it'll be even cheaper than it is here. But it's pretty reasonable. And you can just drill a few holes, screw it together, silicone seal it where you want, and you're away. Just a bit more on the compact stands. It's got, I found another photograph here I put together a few years ago. Small footprint compact sizing allows maximum access in small workshop. Enough front clearance for a 6-inch vise, enough rear clearance for a 4th axis stepper motor, rigid construction with stiff platen bonded to machine base, steep coolant drainage to aim aids swarf transit and machine washdown, 3-foot floor contact to minimize stand stresses with just clear earthquake safety feet. See there, I haven't quite fitted in the rear outrigger feet, but you can see the steep coolant drainage there. So that's just a sheet, 2 sheets, one on each side of stainless with 2 folds in it. I think there's a sketch of that in one of my earlier videos in this series. And then the way that's attached is that you fold it until you're happy with the shape, and then you can put a fine bandsaw blade in your bandsaw and trim the outsides until it's square, and it just drops inside of that cavity there. And then with a felt pen, mark where it butts up against those vertical faces, and cut some steel strips and just tack them in or weld them in. Then you drop that stainless steel pan in there and use some good quality sealant on at least the downhill edges. That works really well. It's really good coolant flow. If I was making it again, I wouldn't put this cavity in here. I went to a lot of trouble to have a cavity there in front of the machine, which drains down into a angled trough. I would just put I would just fill that in there, not level but sort of beveling to the left and the right. There's no need to have a cavity there, it's just more complexity. And then you just get your sheet metal person to weld a couple of circular outlet fittings there, little pieces of stainless tube, just about there at the low spot. I don't know if you can see them very well, you can just see them there. And then just link those up with either a piece of channel underneath going through the base, or some piping or something like that. Channel's probably good, because then if it gets blocked you can get in there with a long wire hook and clear it out. So that's a really good design base. But the 2 improvements I would make now with looking at it retrospectively would be not to bother with that cavity there, and to put the outrigger feet on from the beginning. I added those later to make it a little bit of a broader footprint. At this stage they had those rather narrow adjustable feet there, and they're not so good in an earthquake zone possibly. Alright, so that was good to find that drawing. So the construction of the stand is really heavy channel iron. I picked up a length of that. You can quite often pick up second-hand steel from engineering yards, or you might just build it around what you can pick up, a couple of lengths of heavy box section or channel or something. So it's just essentially a cube carcass and a front and back plate, and it seems to be really rigid. And for panels, you could get a sheet metal shop to fold up some sheet metal squares with folded edges, but really it's quite a good application for plywood. Plywood doesn't vibrate and it's very cheap. Just prime it and fill it, with the famous Bondi, give it a quick sand down and spray paint it. It's not really going to get coolant on it there, so you can just use a can of spray paint, and that's probably the best material for panels, is actually plywood. Just going through some of those details on this very narrow 55-inch wide enclosure. The electrical cabinet is actually the extent of the width of it, and so on the cabinet I've glued a strip of extruded aluminium that this plastic panel drops into. And just looking down the bottom here, it's important obviously to have overlap, so the acrylic or polycarbonate sheet overlaps in front of that vertical edge. The same design on my latest one here. You can see here it's coming down, overlapping that vertical edge again there, coming down beyond there, so the coolant doesn't get outside of the enclosure. So looking at this insert from the outside, there's a strip of steel tacked on and probably sealed against this piece of angle iron here. So, and there's a little rotary, just one rotary knob in a key position here, just a little acetal knob. You just turn it around with a flat on it, and then that opens up, and then you can just lift it out. So it lifts out of that slot in the extruded aluminium that's glued on to the electrical cabinet door. There's just a little blocking strip of sheet metal there, and underneath the electrical cabinet, what have we got here? Just a little piece of angle iron there, and you can see the gap on that side where it goes, and it drops down in front and into a couple of screws that key it in position at the bottom. So that insert is just a panel of polycarbonate or acrylic with a little piece of channel siliconed on the top, just to give it a bit of stiffness and to give it a nice line as well. The aesthetics are important. So that's just a little rotary knob there. If I come in on that, with a cap screw through it, and you can just turn it round. Where has it gone? There it is. You can just turn it round to engage into the frame of the enclosure. And if I'm doing machining with flood coolant, I built this little hatch over the electrical control panel, so that I can just drop the flat down with a little frame. It just keeps the coolant from getting into the electrics, and I do use that from time to time when I'm really jetting the coolant at the cutter. So just going over the sheet metal work, there's a couple of different ways you can do it. You can build a light frame out of angle iron, as I have here, and just buy your own sheet metal and bandsaw it and paint it and build it completely yourself. But what I would do is what I learned the last time, is that because getting sheet metal cut and folded is not expensive, it's more professional and quicker just to sketch up those shapes you want, you know, like that back panel with the angle in the bottom and the folded edges, and just dimension a sketch and get that folded up out of, say, 2mm sheet metal. If you use heavy sheet metal, it adds a lot of stiffness. I mean, that's bracing the whole vertical column of the machine. It adds stiffness, and it doesn't drum and vibrate. You'll find a cheap standard enclosure will drum and vibrate in harmony with different frequencies of machining, and that's quite noisy. If you use heavy sheet metal, you won't have that problem. It doesn't cost that much more, and just makes the whole build more substantial. While we're talking about stiffness, if you're doing fairly heavy CNC work, as I sometimes am, you know, and really loading up the machine, a vibration of the vertical column and of the cutter becomes a limiting factor, and you want all the stiffness you can get. Heavy sheet metal work helps to brace it, but also around the back of the vertical column of the machines. Have you noticed? I'll just go around the back now. There's quite a big hole in the back with just a piece of light sheet metal over it. That's actually weakening the stiffness of the head, and so what I did was got a thick piece of steel and bolted it on with some strong cap screws to actually block in that big hole in the casting. And I did some stiffness tests with a spring preload and dial indicator measuring the flex, and that does stiffen up the vertical column of the mill and make it a more rigid machine. Looking at the back of the column on my other Tormac, this is how they come out as stock, with just a light piece of sheet metal and some light screws there. It's only really a dirt protector cover. It doesn't provide any stiffness really. So if you're doing heavy machining and you want to stiffen up your machine, you might want to put a thick steel plate on there and drill and tap some bigger threads so you can crank it up with some larger cap screws. My left hand end panel is currently removed from this Tormac because of rapid turn, and I've got it off at the moment. Just that's a slightly more refined design, showing the cutout, and a slightly more elegant way of fitting just a piece of stainless steel in there. Let's see if I can show that. Just folded down with some tabs and angled, so the coolant that's running down in that area runs back into the enclosure, and then if you fit a flap, it just runs back from the edge against a little screw here. So the coolant returns back into the enclosure, other than those brief moments when you've got extreme left-hand travel, and then potentially a few drops could get out. And to one side of the base you can fit a coolant tank. I just made one up with a plastic tray. You can just buy a heavy duty plastic tray and let it into a plywood box I made up with some casters on it so you can wheel it in and out, and the chute or channel that comes down drops into a filter box with a mesh in it, and I just put some synthetic cloth on it to continually filter the coolant as it comes through. And I've got a fairly high capacity coolant pump there which allows flood coolant. And you might have noticed that allows a washdown gun, a very handy tool for cleanup. So I probably need to modify the cutout in that end panel to clear rapid turn, but it hasn't really been a problem. Because I've got two Tormacs, I tend to leave rapid turn set up on one and do all of my CNC machining with the gang tooling, and that mainly sprays coolant to the front, so the side is not really needed at this stage, so I'm not in a hurry to make that mod. I did need to cut out a bit of clearance there so rapid turn could do the full Y movement, and obviously I've made up a guard here to guard the motor from getting swarth and chips and coolant into the end of the motor, but I've discussed that in the rapid turn series. So guys, if you're a Tormac owner, something might have occurred to you while you're watching these videos, and if it hasn't, I'll suggest it now. You're thinking about buying rapid turn, or you've got rapid turn. When it's set up on your machine, it takes a wee bit of time to get it all set up and dialed in. Have you thought about buying a second Tormac? Now here's the idea. You buy a second Tormac and you build your own base and enclosure, and it's a neat project. So the actual cost of the CNC mill from Tormac, as you know, is only, what is it, 8,000 or 9,000 US dollars, and then you just build the rest. Very low cost. Then you've got a second machine. There's no rush to get it built because you've got your first machine here running. Then you can have one set up as a mill and one set up as a lathe, and it's really relaxing. And if you ever have a breakdown in the future, you've got a full replacement set of all parts, and you can switch from one machine to another and keep your urgent job going. So there's a lot to be said for having two Tormacs. Oh dear, I'm sounding like a salesman here, but this was partly my logic. And you can build a second CNC for a very low price if you build your own stand and enclosure and monitor stand. All right, hopefully I've tempted some of you. And that will be an additional sale for Tormac to make up for their loss of sale on the enclosure and stand. Cheers. Don't get me wrong, I'm not just promoting having 2 CNC mills in every situation. I mean, rapid turn with gang tooling suits automatic CNC turning of small parts that are not high precision, and so that will only be applicable to some people. If you want to do large parts or high precision parts, you're better off with a standalone CNC lathe such as Slant Pro. So obviously, horses for courses, it depends on your situation. It may well be that Slant Pro would have been a better decision for me in the long run too. In fact, if you can see 2 steps ahead, and one step is rapid turn and the second step is Slant Pro, and you can see you're going to end up there, then act on the second step and save yourself a lot of time and money. You know, but there will be some people where they're doing 90% milling, and having 2 mills makes a lot of sense, and rapid turn makes a lot of sense for if they have a small amount of low precision turning work, small diameter turning work. Well, that wraps up the series on build your own stand or enclosure. I've really enjoyed building that enclosure. If any of you guys decide to build a stand or enclosure and you want to pick up on some of these ideas, you're welcome to copy them. Please, if you have a minute, take a photo, do a video. I'd love to see what you've built somewhere else in the world. Post it to the forum CNC Zone or to the YouTube video comments, or send me an email, cliffhalldesign@gmail.com. It's really good to be in contact with you people out there, other crazy folk doing similar things. All right, cheers.